Well, welcome. We are going to talk as a follow-on about Python packages. This is something you need to understand if you're going to be using Python. Okay? So, a couple of reasons why you're going to want Python packages. The first one is convenience, and the second one might be a requirement depending on your system. So imagine you have your own computer. Your computer, like the ones at least my students are using, have Ubuntu 2004 on them. And that computer is sitting in the lab, and it came and it has a version of Python pre-installed. Okay? Now, what if you don't want to use that version of Python? What if you need a different version of Python? Okay? Or even if you're happy to use the system Python, you really don't want to be messing around with the system Python. It's easy to mess things up and screw up a machine by doing things in the wrong order incorrectly. Okay, so that's the first thing, is you really won't want to touch the system Python. You want to leave it intact because, is that legal? We do it in church, right? Okay. Your operating system is reliant upon the system Python that's there. I know when I first started using Python, I built myself a Linux virtual machine, and I said, oh, I don't like that version of Python. And then I spent half an afternoon trying to figure out how to upgrade the system Python, only to find out that was a bad idea. Luckily, it was on a virtual machine, and I blew it away and started over. So that's the first thing. Now, the second thing is that not only do you not want to mess with the system Python, but if you don't have administrative privileges on the computer that you're on, you might not have the ability to install a second Python. We're actually going to talk about two ways to solve these problems. Okay, so here on what you can see on the screen, I have the goals. The goals is we don't want to touch the system Python. We want to be able to install as many versions of Python on our system as we want. We don't want to be stuck with the one that the system came with. Okay? For example, you've written some software and you just want to make sure it works on every version of Python from 3.5 to 3.9. So you're going to want to be able to run it through all of those. Okay? And we want to be able to create what we call sandboxes or containers to hold a Python environment. So I want to be able to create a Python environment with Python version 3.7. And I want to put NumPy and Matplotlib and pandas in that one. And I just want to work there. But then I want to be able to create a different environment with Python 3.9. And I don't want all that gunk in it because I'm doing something completely different in this other project. And so we're containerizing our Python, so when we add new packages, they only apply to the sandbox or the environment we've created them in. Now here's where this can sometimes get you. You have two projects you're working on, and this project is using a certain version of some package, but that package needs a specific version of package, we'll call it package X. But then you start working on some other project and you need a package for it. And it also depends on Project X, but it requires a different version of Project X. If they're all shared together in the same directory, you got a problem, right? You've got two things that need different versions of X. So this containerization is our second goal. Don't mess with system Python and isolate your Python environments from one another. And that will really help. Okay, so those are our goals, and there's two ways to do it, and I'm going to walk you through both ways, and you're going to have some activities at the end, and then you can choose one. They are so close to being equivalent that you could argue forever about which one is better, and I keep flip-flopping. I decide I like one, and then I decide I like the other. They're not bad. So the first one is called venv. Okay, venv is built into Python. All right. And what you do to use venv is you have to have administrative privileges and you're going to install a whole new Python into your system. And it's going to live in the system directories. That's why you have to have sudo privileges. Okay? But it isn't going to be called Python. It's going to be called Python 3.8 or something. And then you're going to use that with the venv package to create an environment. So let's do it. So the first thing we need to do is we need to do sudo apt update, and then we need to install some stuff, and we need to add a repository, because this repository, this dead snakes repository, I can make this bigger by the way. Oops. This dead snakes repository is where we're going to find these versions of Python. So I'm just going to copy this command. I've already done the sudo apt update, and that takes a second. Okay.
Hey, Dr. Nelson,
Yes.
that's only because you're on Ubuntu 16, right?
I don't know that. Okay, so when you're on Ubuntu 20, you don't have to add the repo?
No.
Okay, I didn't know that.
Or 18.
Okay, I'm doing this on 16, an old one, specifically because it comes with an old Python, and I wanted to show how to add newer ones. So that's good to know. You do not have to do that. Okay, so here we go. Okay. Hey, come on, what's going on? Okay, come over here and do copy. Come over here and do paste. Okay, it wants to know my password. Okay, and if I knew my password, that would help. Okay, there we go. Okay, so I've added the repository. No, yeah, that was one. Problem is I did all this before I came, and so maybe the repo's already added, but we'll try it once more. Okay, the idea of adding, oh, it wasn't added. So the idea of adding a repository is the following. Python understands there are certain places where it can get software from. So as you add packages to an existing installation, there is a set place it goes to look. So all we're doing is saying, hey, when I say I want to do something, I want you to add this particular repository for me. Okay, in this case, we're using the built-in Ubuntu package manager. Now what we can do is once we have told it about this new repository and we do an update, what it's doing is it's going out to all of its repositories it knows about, including this new one, this Dead Snakes repo, and it's building an index of everything that is out there. So it has a nice table. So when you say, I want to install blah, 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 it knows which version to go grab, okay? So that's what we're doing right now. Anytime you go to install new software using apt, this is not Python yet. This is still your Ubuntu apt install, apt get install, okay? This is how you add packages just to your Ubuntu in general. Anytime you're going to do that, it's good practice to do a sudo apt update just before so he can refresh his tables. Okay, so what just happened here? What did I just do? I did the sudo apt update. So now what I'm going to do is I'm going to install, let's install Python 3.9. How's that? Whoops. Okay, so sudo apt install Python 3.9. This is normal Ubuntu stuff, okay? The -y says answer yes anytime asked. So you don't have to sit here and wait and type yes when it says please confirm. So what this is doing is it's going out to a repo. It is grabbing an installation of Python 3.9 and it's putting it into my system directories. And that's why I had to preface it with sudo, because as a normal person, you don't have the ability to write things into the system areas. And sudo is the thing that gives you the super user privileges to do so. So you can see it setting up Python 3.9. You say, well, where are these user areas? Well, user bin is one of the standard system areas that's protected. And in fact, if I do this, whoops, what you'll see is in user bin, we have Python 2.7. We have Python 3.5. Those are the ones this version of Linux came with. I installed Python 3.6 as I was preparing this talk, and we've just added Python 3.9. So we have 4 versions of Python sitting out there, okay? So if I type Python 3, I'm going to get the one that was built into the system. Okay, but we're not going to do that. Okay, the next thing I have to do is I have to actually grab the virtual environment module for Python 3.9. So that's this next step, and it's going to install the Python 3.9 virtual environment. Okay, and that one's doesn't take as long. Now, you only need to do this if you don't have the version of Python on your system you want. If you're happy with your system version of Python, all of these steps we've just done aren't needed. The second half, though, is we create these little virtual environments. You'll want to do that. Okay, here we go. So here's our virtual environment module is being downloaded. Okay, now we're ready to go. We have 4 versions of Python sitting out there on disk, and we can make virtual environments using any of them. So let's make a new virtual environment, and we're going to call it my venv, and we're going to put it in my home directory. You all know what tilde means by now. Okay, so this says run Python 3.9, not the normal Python, the Python I just installed. Run the module called venv inside that Python 3.9 installation. And then the other parameter says, I want you to create a virtual environment called my venv. Okay. It doesn't take very long, just a second or two. And now if we look, I have a directory that's called my venv. Can you see it? Okay. I've got a my venv directory. If I go into my venv, let's go see what's in there. Okay. Well, there's a pyvenv.config, okay, which says where the Python it's using comes from. It's version 3.94, and do not use any system site packages. That just happens. You never touch this file. I just wanted you to see what's there. There is a bin directory. What is normally in bin directories, everybody? Executables, right? Bin stands for binary, and that's another way of saying an executable. So if we go into the bin directory, you can see there's a few things here. But notice there's something called Python. There's something called Python 3. Okay. All right. There's Python 3.9, et cetera, et cetera. What I want to do is I want to activate this. This does a number of things. Okay. Whoops. That's not what I wanted. Go back. It is what I wanted, but it didn't work the way I thought it should. Okay. If you don't like your environment, you blow it away. Okay. And this is one of the beauties of this. You can create an environment in 3 seconds, and you can blow it away in 1 second. Okay, let's try it again. Where's my, okay, there we go. All right. Now, typically the way you enter an environment is you source that activate file, okay? Whoops. Okay. And when you do, it does a couple of things. First thing it does is over in your little prompt, it now adds some extra text to remind you you're now in that environment. It also modifies your path, and you know the path is where the shell looks for commands to execute. It modifies your path. And so if I type Python, I get 394, the one I just installed, not the system Python. Okay? And in fact, you can verify that because you can say, which Python am I going to get? I'm going to get the one in my environment bin Python. So what it's done is it's replumbed your environment so you don't even see the system stuff. You only see the stuff in your environment. Okay? Now, when you're in the environment, you can do all the normal sorts of things, right? I need the pandas package. So pip install pandas. Okay? And it will install that in that environment. So the key is, other than installing the original Python 3.9, from here on out, I never touch the system. Nothing needs sudo because it all lives inside this little my venv, okay? And so that's the beauty of this. So if you're on a system and you don't have sudo privileges, if you're happy with the Python there, you can still use venv to make all the environments you want. Okay, any questions so far? That's not very hard, is it? 2 steps. Install a new Python if needed, if you don't like the Pythons that are on your system. That requires sudo. Step 2, make a virtual environment. Step 3, you already saw. Erase your virtual environment by just blowing the directory away and starting over. There's no meta files, there's no other stuff left around on your disk. It's just that my venv directory, okay? And so a lot of people like venv because it's built into Python. So that's a plus, would you all agree? You don't have to get some other package manager, but you have to have sudo privileges if you want different versions of Python, okay? It's the lightest weight approach. Now, here's a caution. In preparing for this talk, I talked to every one of our computer engineering faculty. I got 0 consensus on the right way to do it, and I got tons of, I don't know, I messed around for a while and I found something that works. The way to do virtual environments in Python is a total mess, okay? It has been, there's like 5 ways. I made a little list here. This is all on the web page, by the way. But you might read about virtual env. You might read about venv. You might read about virtual env wrapper. You might read about pip environment. You might read about pi environment. You might read about pi venv. There's like 20 ways that people have done this. So I've shown you a way that we think is probably works, okay? And when I say we, Dr. Gozer and I have been haggling over this for a week, trying to come up with what we think is the cleanest approach, okay? Is there a shortcoming of this? Not really, okay? But there are other approaches to doing this where they provide an actual environment manager. So you can list all the environments on your system and you can, delete them and do things. And they give you a little bit of control by putting all the environments in a central place. You might think that's helpful. You might like that. Here, you can put a virtual environment anywhere in your file tree you want. It doesn't have to be in your root directory, okay? It's just, it will create a directory wherever you tell it. It will put a bin directory in there with the activate and all the scripts and the pointers to the Pythons, blah, 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 okay? All right, but there is a second version we're going to teach you.
Question.
Yeah.
How does this compare to like a Docker? I mean, Docker is
These are what I call super lightweight versions of Docker, okay?
Python only kind of?
Yeah, okay, I'm glad you said that. This approach, this venv approach, only can do Python packages. That's all it can do, okay? But if what you're doing is Python and that's all you need. So these are kind of containers. Docker is a much more powerful general purpose containerization, okay? But yeah, these are like a container. The only downside I can see is that you have to have sudo privileges because you're going to install new Pythons into your system, okay? But as you can see, it works well. You activate environments with a command. And if I were you, I would go into your .bashrc file and I would add some aliases. So you can say my environment and it just sources that, blah, 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 /bin/activate script. Okay? And I would make an alias for deactivate because that's too much typing. Mine is called DE. Okay. And create, activate, deactivate, and remove environments at will because it's a second or 2 each. They only take up maybe 10 megabytes of space for an environment. So you really should make one environment that has everything you ever think you might want because you think somehow you're saving space. I make environments for every little sub-project I work on because they all need something different. I also find I blow them away regularly when I screw them up. And so by separating them out, that makes it nice. Now, there is a competing approach which does provide 2 things for you. It does not require sudo. Everything it does is 100% user space. So even if you had to log into a Cadem computer, you could do this because you're not going to put anything into the system areas. That's the first thing. And the second thing, I don't know if it's all that valuable, but it does provide this management of your environments. And then the third thing, which I haven't used yet, is that it allows you to containerize things in addition to Python. It isn't just Python. You can put other things in Conda containers. So let's quickly run through that. It's called Conda. Okay, whoops, come over here. And by the way, you can see that everything I'm talking about is from our bootcamp page. Okay, Conda was developed by the person who did NumPy, who used to be a BYU faculty member, okay? And it was developed to address problems that these other approaches didn't do. So it obviously is a little more powerful because it can do things that they thought was needed. Okay, so it's a bit more full featured. Now, some terminology, just so you don't get lost. Anaconda is the following. It's a whole bunches of NumPy and scientific numerical data science tools bundled with this Conda environment manager. And it's big. It's, I don't know, 5-8 gigabytes in size. But they also distribute something called Mini Conda, which is just the environment manager. So we're going to use Mini Conda, okay? And then Conda is the tool that comes with Mini Conda, and it's kind of like venv, all right? So how do we do this one? Well, you got to go get yourself a copy of the Mini Conda installer, okay? And so this is the command you do it, okay? So, all right, I'm going to do that. Oh, by the way, well, I probably want to deactivate this other environment, right? Okay. Then the next thing you want to do is you want to run bash on that installer script, okay? And it says, do you want to install? Yes. Please read our user's license. After a while, I get tired of reading. I hit Q, say, I've read it. Do you accept the user's license? Yes. Put it in the default directory and do an initialization. So here in a second, I'm going to say yes for the initialization. And so what I'm doing is I'm installing Conda. So this is the downside of Conda. This is a third-party piece of software I'm installing into my home directory, okay? And it says, do you want to initialize things? Yep. Okay. So what I've just done is I've created a directory called Mini Conda 3, and all the environments I create are going to live inside there, okay? And the other thing is, if you look at my .bashrc file, it added some gunk to the bottom. You see this? This is a Conda initialization thing. Does everybody know what a bashrc file is? It's that thing that gets sourced every time you open a terminal. Well, I'm going to resource it, okay? Oops. Okay. All right. And then there's this other command down here where it says, you know, by default, every time you start up, he's going to create, or he's going to open a base environment, and I don't want that. I don't need no base environment. Okay. At this point, I have installed no new versions of Python, have I? I've only installed this Conda installer. So now let's make a Python environment. Okay, where is it? Come on, right here. Okay, let's create a Python 3.7 environment because I know there is no Python 3.7 on this system. Now this is different than the venv approach because this is going out into the web and it's pulling a new version of Python 3.7, but it's putting it in my environment, in my user space. It's not installing it into the system. And that's why I didn't have to sudo to do it. So that's kind of the advantage of it, right? You don't touch the system. And then, you know, just like before, you activate environments, but they have, since we have a command called Conda, okay, I'm going to Conda activate the environment I just built, and the environment I just built is called conda-env. It puts its name over here, and otherwise it looks just like venv. You can pip install packages into it, or you can do Conda install packages into it. The web claims the Conda dependency thing works better than the pip one. I've not run into it. You haven't either.
No, I don't use it.
Yeah, I mean, but they claim that for complicated dependencies between packages, Conda does better. I've never run into that. I use pip install inside my Conda environments, so, and it has always worked. And of course, then you can do Conda deactivate. Okay. So looks a whole lot like the other one, okay? So you now have seen two ways to get a specific version of Python in its own little container. You can see that you can activate them, you can deactivate them. It's pretty easy to do. The difference here is these are stored in your mini Conda environments directory. Okay, and in there, there's a Conda environment. And as you might guess, it has a bin directory, etc. If there is a difference, it's that with Conda, everything is Conda space command. With the other one, it's just shell commands, right? It's do this, do that. So for example, I can, so that's Conda environment remove the environment named Conda end, and now it's gone. So now you've seen two ways, okay?
Is the Conda executable? Like if you did like which Conda, is that just in your user, your home directory?
It's in your home directory in that mini Conda directory. So if you say, oh, I want no more Conda on this system, I don't like it. Whoops, I got to go to the, here we go. Okay, Conda is now gone off my system. So that's the nice part about Conda. It kind of centralizes everything. So, you know, so other methods, they create little dot directories that you don't see, and they put, you know, create all this metadata. And I like these two approaches because they're both pretty clean, right? So, all right. Another thing you can do is when you create, well, it's too late because I blew away my Conda. When you create a new environment, at the end of that line, you can list all the packages that you want installed into the environment to initialize it. Okay, that's you might find that easy to do rather than create the environment, activate it, go inside, and start adding things. Another thing with both of these approaches, there's a way to essentially take a snapshot of everything you've installed into the environment with pip install or Conda install, save that into a file, and then later you can say, make an environment that looks just like what is described in this file. So it makes it really easy to clone existing environments, and both approaches have it. So up to you to choose which one to use. There's some self-paced activities we would like you to work through as a part of this week's Python activities. They're on the page, and they basically just walk you through creating a few, doing some experiments with venv and just kind of understand how they work, create some environments, delete some environments, do the same thing with Conda. Okay, I don't know why Conda has a thingy over the A at this point. I don't know. Repeat it with Conda, learn how to save and recreate environments. We're not going to show you how to do that here. And then choose a method and start using it. But in fact, if I were you, I would, in your .bash RC file, I would activate the environment you use most of the time. That way, you're always in an environment and you're not going to mistakenly start trying to put things into the system and get permission problems, etc. So that would be a way to do it. Okay, anything to add?
Well, I was just gonna say, I mean, I like the idea of using, I'm not sure how I would do it with Conda, but I like the idea of venv of, you can just have a environment for your project, and this is a great time to put it in a make file instead of telling your team members, oh, go make an environment and put these packages. In your project, you might just have make setup environment, and it creates the environment for you, and you wouldn't commit the environment into GitHub or anything. It's something you would put in a make file, and everyone on the team could have a similar environment. So.
Yep. And you can do that with either one, because they're just commands that it executes.
But
Now the cool thing about, Project X-Ray has this cool idea of every single rule in the make file requires this rule called in environment to be satisfied, which basically goes and says, am I in the environment that all of these make things are intended for? And if not, go activate it first and then do your make to make sure that the make file is putting stuff into the right environment, correct?
Yeah, I was just gonna say with Conda, then I kind of have to assume my team members have Conda installed, I guess.
That's right, that's right. Yep, so for that, so that would be a downside of using the Conda Pro.